So we're now going to print 16. We're just here for question 1. For question 1C, which is saying express 1 plus 2 root 3 over 2 minus root 3 to the power 2 in the form P plus Q root 3. So you know the rules of the game here. When you see a square, you can even get that thing and do it down here. This is the same as 2 minus root 3 multiplied by 2 minus root 3. 2 times 2, we get 4 minus 2 root 3 minus 2 root 3. And then negative times negative, we get plus. Root 3 times root 3, we get root 3 squared. We all know that the root and the square cancel each other whenever they meet. And then negative 2 minus 2, we get 4. And then here we are going to have plus 3. This is the same as 7 minus 4 root 3. And then get back our expression now to be 1 plus 2 root 3 over 7 minus 4 root 3. And then now at this point we rationalize, so we multiply the numerator by the denominator piece. Where there is a minus, we put a plus. 4 root 3, and then we put a plus 4 root 3, which is equal to 1 by 7, we get 7, plus 4 root 3, plus 14 root 3, that is 2 by 7. And then now we have to be a bit slow here. 2 multiplied by root 3 by 4 root 3. You first say, what is 2 times 4? You get 8. And then root 3 times root 3, it is root 3 squared. So the square will take away the root, so we'll have 8 by 3, which is 24. So we come here with 24 over, here you just need 7 squared minus, because negative times positive, you get minus, and then 4 root 3 squared. This is the same as 7 plus 24, we get 31, plus 14 plus 14 plus 4, we get 18. Root 3 over 49 minus 4 times 4 is 16. 16 multiplied by root 3 times root 3, which is 3. So I'm going to get 31 plus 18 root 3 over 49 minus 16 times 3, that is 48. So 49 minus 48, we get 1. So 31 over 1 plus 18 root 3 over 1 remains just that as our solution. Not much complicated. This is the best time to ask questions. Shall we ask?
Sir, how did you multiply the denominator?
Which denominator?
The 7 minus 4 root 3 multiplied by 7 plus 4 root 3.
So here we just avoided going the longer way, because if we go the normal multiplication way, you'd say 7 times 7, which is 7 squared, plus 7 times 4, that is 28 root 3, minus 4 times 7, that is 28 root 3, and then minus 4 root 3 times 4 root 3, which is 4 root 3 squared. Then this guy and this guy give us a 0. So remain 7 squared minus 4 root 3 squared. That's how we just took it like that, because that's actually what we call rationalization. Then now 7
Okay, thank
squared.
you. Okay, thank you.
Okay, so let's go to question 2. On question 2, we want part A. A1, it's saying let A be equal to X, a real number, such that X is greater than 2. And B, X is an integer, such that X is less or equal to 2. These B subsets of R, where Z is the set of integers. Find a set A union B complement. By simplification, we know that this is A complement intersection B. Now let's go back to our actual sets. A can be written as negative infinite. I mean, it's greater than 2. So you start from 2 all the way up to infinite. That's R. Then what about integers? Integers. Less than 2, so you say from negative infinite up to 2, including 2. You can do this knowing that X is Z. So we are talking about integers that lie in that interval. Not everything in there, but just integers that lie in that interval. Okay? Then from there, to get A complement intersection B, A complement is going to be, since if you go on a number line, A runs from 2 to infinite. This is A. Its complement will include 2 and go to the left. This is going to be A complement. So you say, in interval form, it is negative infinite up to 2, where you include 2. This is A complement. Now, this A complement intersection the other guy. Then you're going to say this set, you don't present it as an interval. Because of this, you present it as set with integer. So I'm going to say X, an integer, such that X is less or equal to 2. This becomes the solution. If you just say this is equal to negative infinity up to 2, it is wrong because you have not said in which set it must lie, because integers are subsets of real numbers. So when real numbers are, when R is the universal set and you have integers, you take Z in R and present as a solution. This is where we are facing a lot of challenges in that task I gave you.
Sir, what if the way we wrote it like negative infinite to 2, which it was included. Now, what if 2 wasn't included? Then in the certain Juda notation, the sign it was included. How do you go about research?
No, you can't include it. It's not included anywhere when you get in the intersection. You can't include it anywhere if you're getting the intersection.
Okay.
Yeah.
Hello? The point is this. Z is a subset of R. Integers are positive, negative plus 0 whole numbers. Negative 2, negative 1, 0, 1, 2. Keep going this side. Keep going this side. These are integers. So when you're intersecting integers with real numbers, you get integers as an intersection. Because all integers are real numbers, but not all real numbers are integers. That's the reason why your set for your solution becomes integer.
But why wasn't it just negative infinity to 2?
Because negative infinity to 2 just is in R. You understand that between negative infinity and 2, there is also 1.003, which is not an integer. So you have to specify that in that interval, I'm just picking integers. Things that you ignore when you're studying.
No, sir.
You know?
Sir, sorry, I didn't get the point. You are saying that if you have the real numbers, then intersecting with the integers, you get the set of integers.
If you're intersecting real
So
numbers,
even in that question which you are solving, that which you gave us as an exercise, we are supposed to do the same. We are supposed to get the set which contains the integers.
yes. Like that. Things that you ignore. This was a question in the exam. State, when you're studying, this state Demorgan law. Actually, they have said laws. State Demorgan is laws. There are two. One, A intersection B complement is equal to A complement union B complement. This one is called the intersection law. Demorgan. Should they specify that it's stated the intersection law of Demorgan is, then you state this one. If they say union, you state this one. is A complement intersection B complement. This is union. And we have used this several times.
So when you're taught to state, you're just supposed to write that. You're not supposed to explain.
You just did. What can you explain?
I think she meant in words, like you said it in words.
No. Just like when they ask you to say when the function is even or odd, the job is to say even when f of negative x is equal to f of x. When f of negative x is equal to negative f of x. Full stop. Note the function is said to be even when if you take a negative there and then attach it to x, then you go to f, and then when there is x in f, you take a negative x. you just say this.
This is Leo.
It's not something to dig out. Okay, next. So you mostly when you're starting, you ignore this, but you use it when solving. Now, should they ask you to state it in this way? Then the third one.
Sorry. Yes, on the first question, why was it x is greater than 2? Because the solution set was just negative infinity to 2, and 2 was included. But why was it greater than 2 when it just ended up to 2?
What do you mean by that? The solution is not greater, it is less or equal to 2. This is less or equal to 2. A was greater, so its complement will be less. That's why it is less. We're interested in the complement of A intersection B. In B, there is less or equal to. In the complement of A, there is also less or equal. As you think?
All right, thank you, sir.
Okay, but you're still thinking. Then given that X and Y are sets, simplify X intersection, X complement, intersection Y, complement, everything complement. You take complement inside first. So we're going to have X complement, the intersection will become a union, and then we'll have X complement, intersection Y. The complement just means X complement intersection Y. And then from here, as you can see that X complement is appearing outside, it's also appearing inside. And yet we have union and intersection. So the answer becomes X complement. And we talked about it so many times.
So if it was intersection and intersection, absorption doesn't.
Intersection, then absorption becomes more stronger.
Sorry,
what if
A intersection B intersection A is A intersection B.
Can I please see the previous page? Thank you.
Now, sir, there I'm behind. How have you concluded that the x complementing union, x complement intersection? So you get the one which is common. That's what.
Yes. Again, the one that is common.
Now, so what about if you have like, let's say we have got a complement, x complement, and then inside there we have got just x. Which one can you choose?
The two sets are different. So you leave it as they.
Thank you.
Exactly. I'm flipping here looking for questions in other past papers. We're now in 2015.
The one that you gave us the exercise in the afternoon.
But you understand that very few teachers would like to answer their own question. do you know that? In 2015,
No,
we're interested in question 1A, part 1. Express the complex number 2 minus 5i over 3 minus I in the form a plus ib, where a and b are rational numbers. Expressed in the form a plus bi, or ib means the same. So this then becomes, you go straight to conjugating. You multiply the numerator by the denominator, except in the denominator, you change the sign of the I, or the coefficient of I if it is not just I. This becomes 3 by 2, we get 6, plus 2i minus 15i, and then I times I, as we agreed, I squared is equal to -1. So if you want, you can be writing -5i squared, and then you go down and get this 3, have it squared. Or if you are good at making mistakes, then avoid the shortcuts, just go by the multiplication. 3 times 3, 9, plus 3i minus 3i minus I squared. Then this becomes 6 plus 2i. Here you can now add. So 2i negative, in positive 2i minus 15i, we get negative 13i. And then minus 5 multiplied by -1 over 9. 3i minus 3i gets 0 minus -1, which then becomes 6 plus 5 minus 13i over 9 plus 1, which is equal to 11 minus 13i over 10 over 10. This is the form that has been asked.
So now, sir, in an instance whereby the one with 5i is swapped is the one which is starting, then the constant is the in front. So what do you do? Do you need to interchange them, or you just need to go straight?
If you have 5i, if you have this plus 2, or the one in the denominator,
the one in the numerator.
well, you just proceed. Just take it as it is. Then,
Ah,
hello.
is it wrong to leave the answer on the second last page?
The question says you must leave it in this form. That is what the question says.
But there's over 10 there.
So you follow instructions.
Yeah.
Sir, but don't we have
Yeah.
to feather the final answer, like the common denominator?
No.
Because that the answer
but-
is different. The form they want and the answer.
Mm.
Yeah, but there's an addition sign there, and that's a minus, and it's a fraction.
Yes, sir.
It's real.
You cannot look. The age of 10. If you, this is where I'm coming from. It was 11 minus 13i over 10. But the question says, leave the answer in the form a plus bi, where one is able to see which one is the real part, which one is the imaginary part. Now the imaginary part is the coefficient of I. The real part is the one standing alone, that I. Now you want to leave it in this form so that the marker should finish for you, right? They will finish for
No,
you.
sir. In most cases, when we're solving such questions, it always ends up being, if it was given as a fraction, it would turn up to be a fraction, but that wasn't a fraction, and it was an addition sign, and the answer had a negative sign.
I can't get now. I don't know what you mean by the addition sign. The negative sign. Oh, on top there. You mean this?
Yes, sir.
Also,
No. That one should not bother. Look, this is the same
so,
as
sir, if you
11 over 10 plus negative 13 over 10 I. But you and I know that whenever positive and negative meets, positive is neutralized to this.
So, sir, if you just leave it where there's 11 minus is 13xi over 10 everything, you lose the mark.
No, there's no extra. 13
No,
I.
yes, sorry.
If it was 4 marks and the examiner is in a good mood, they will finish up for you and give you.
So if they're
4
in the
marks.
bad mood, you lose one.
Exactly, they'll give you 3 marks. This is not the form that you asked. I imagine losing a mark because you're taking the law in your own hands.
But sir, that's not fair.
To disobey. Okay, so let's log out. You can start a new question here. Let's log out and come back. Let's be quick.